How's it going, everyone? And thanks for checking out this video on deploying Elixir transaction problems. This video is a recording from my Twitch stream where I went through and debugged an issue that had to do with duplicate transactions occurring in Stream Closed Captioner. This is an example of a common problem I learned about in school called the ATM problem, where there's a race condition between two transactions and what can happen. So in this VOD, I've sliced down the stream down to roughly about 15 minutes, going from talking about the problem to finding a solution and testing that solution. If the length of the time is a little bit long for you, you could try bumping it up to playing around 1.25 times the speed to 1.5 times the speed. Potentially that can work for you. But hopefully you enjoy the video and you learned something from it. So the way I found this issue was I always have an eye on New Relic, and I saw that there was a spike in errors during an interval of time. So if we go to 24 hours, I saw this lump of errors right here. And these were some unusual errors where this get channel info was happening. This Twitch activation, it wasn't expecting more than one. And it was causing issues. And it's because there was more than one of this record in the database. So I was luckily able to go into the database, went into my admin panel and deleted that extra record, and it solved it. But it's highly concerning that it happened in the first place, so we need to figure out why it happened and make sure to fix it. So let's go over to the captions pipeline, this translation section right here, and take a look at this. So it goes get user active debit. It goes into here and it tries, so if the user doesn't have an active debit, it goes into here, which tries to activate the translations for the user. And then let's go into here, and then right here's a multi. Okay. So it attempts to activate the translations for this. Oh yeah, this will totally break. All right, so the problem with this is that we look up bits balance before we actually enter the ecto multi. So it's not protected by any sort of transactional logic for that first initial lookup for bits balance. So when we're in the middle of processing a transaction and trying to deduct from the balance, another process can come in here and then grab the balance, which has yet to be deducted, and then go in here also. So this portion right here, basically this check, this query and this check need to occur as part of our multi-step. So this would be all right, so we do this, and then we're going to operate on that action next. So we're going to try to do this right. Get bits, get balance. And this is specific for the multi. So for getting the balance, we get the user coming in, and we don't care. So this is going to be returning back in an anonymous function that the ecto multi is going to operate on. What we want to do is move this into here. So I am going to comment that out for now, so we can just see what the payload's supposed to be. So here we call get balance, calling in the user, or passing in the user, and then what we need to do in this call is do this check. So we have the user, and I want to check if the user has greater than 500, greater than or equal to 500 bits. If they do, we return back an OK. We throw an error. And the error is going to be more specifically that insufficient balance. Insufficient balance. So then this goes away. And we're left with this. And this is what's supposed to happen. And then we can just, I don't know. I'll just return back the user. Well, I guess I do have to return back the user because this user is the one with the loaded bits on it. So then what happens here is that we do get bit. So we get balance goes into here, which this will create a balance debit. And then that will get down to here where it'll update the balance. Or we do the subtraction. And this needs to grab the get balance of the previous transaction. The user. I'd be curious to see if I can somehow replicate this in the test. I basically would have to call this twice in an asynchronous function. All right, let's see here. So we have two tests running. Test bits balance debits active translation, an insufficient error of the user. And so both of the tests, or one of the tests for activate fails, insufficient balance. It returns back an error with bits balance insufficient balance. All right. We don't, so I don't really care about that, and I don't really care about that for the test. Test concurrency. So I think if we call two tasks, this might, I was thinking about might be the way we do this. Let's see if this actually will work though. Task 1. Task 2. I need to do this task 1, task 2 test down here. Not for the failing one. We need to double check that the balance. I want to see if I can trigger. So this is an assertion with task 1. This one is task 2. We're doing the exact same thing. Let's see here. So that failed online 44. So this didn't do exactly. Oh, wait. Duh. Because it needs to be a task await. We need await for task 1 and task 2 to resolve. So it's like promises, JavaScript promises. We move things to a promise to happen asynchronously, and then we await on that promise to resolve. So that passes. Interesting. I would have expected one of those to return back an error, but again, we're kind of treading on new territory with trying to test, making intentionally a transaction fail, replicating the issue that we saw. All right, let's see. So let's do this. User, do we have access to the account? We don't. Let's alias accounts. because I want to query directly for this user. Created user. I have a suspicion here. So accounts, get user, created user, ID, boom. All right, there we go. I got it to happen. All right. Yeah. So I needed to pass in a fresh user instead of having a user that already had its bits balance already preloaded. So when inside of the active translation 4, when it tried to preload when it tries to preload the user bits balance, it's like, hey, you already got it there. I don't need to do anything. I don't have to refetch it. So I wonder if there's a way to force preload. Let's take a look. That's actually a very, very good thing to think about. So preload. Force. Yes, we can. Force. By default, active won't preload associations that are already loaded by setting this option to true. So this little weird hacky thing we just did right here, we don't have to do. This is actually a potential bug under the hood. If we happen to accidentally pass in a user with the preloaded bits balance. So I have to do force true. So this test was good because we've actually surfaced another potential bug. So force true. If we go back to our original test here, where we're creating a user and already preloading it, preloading the user struct with bits, that it should go ahead and try to preload it anyway. And we should get an error with this whole thing. We don't care what the last item is in there. Woohoo! That was a good test. That was a really good test. This is a really good test. It found a potential thing that I would have never thought about. So we have our test. It works. We think we're replicating the transaction issue here. The question now is, if I stash my changes for this file, the fix. So let's actually see if our test will test the concurrency race condition. That's the one thing we still don't know. We have a test that tries to test the transaction issue, and which is great because we surfaced an issue. So I'm going to try stashing the changes for the file. Now let's see if our test will actually uncover the bug before the fix. It accepted it. It said okay. So there we go. This test actually accurately tests the concurrency race condition. What we can do to doubly make sure is this is still trying to preload the bits balance on the user. So we don't have that forced preload fixed in yet either. So let's do a triple check on here, because it could just be a fluke. It could be a fluke because we're not doing a forced preload. So let's go ahead and do accounts get user, accounts.get user, and user ID. Now let's run this test again. So now we're eliminating the chance that the logic without the forced preload, because we're preloading the bits balance here. So we're getting a user that already has a bits balance set on this. So now we're getting a clean user that doesn't have any preloaded associations on there. So both of these executions separately should try to preload the bits balance. All right, so the failure still happens. So here we have it. We have the we have two tasks. Two we call the activate translations for asynchronously, two actions for this, and it allows the first one through, and then the second one and then it allows the second one through, and it does the bits balance deduction also. So it doesn't throw an error that the bits balance check inside the bits balance check that there's an insufficient balance, because we don't check for the balance inside of the transaction block. So this happens outside of the transaction block, which is the result of the raise condition. So if I were to go in here and do a git stash pop now with the exact same test code, just with the fix, let's see what happens. So our test properly checks, does two asynchronous tasks to activate the translations. The old code failed. It allowed it. It said, okay. The new code blocks it.